Hello everyone and welcome to today's edition in which we'll be looking at computers and we are considering pseudocodes. So now, a pseudocode is simply a statement or a step-by-step procedure which interprets the flowchart. So we're looking at how to convert a pseudocode into a flowchart. So the question says, the program below is given in form of a pseudocode and then this is the pseudocode from start up to stop. So the question says, draw a corresponding flowchart to the above pseudocode. So now, what is important when drawing a flowchart when given a pseudocode is simply to know when to use a particular shape at what stage. So now, the first part there says start. So it is important to note that when starting a flowchart, we always use an oval. So you draw an oval like that, and in it you write start. Then the next part says enter radius. So when entering information into a computer, we use a parallelogram. So you write a parallelogram here, and in it you write R, enter R, just an initial R. Then you connect with an arrow pointing downwards. Then the next part says, if radius is less than 0, then display error message and re-enter positive radius. So now, this is a situation where we are giving room to errors. When you are entering information in the computer, there's a time when you enter the wrong value. In this case, suppose you entered the wrong value of the radius. Maybe you have entered an incorrect value, which is a negative value. So now, we are supposed to give room for errors. So to answer that, we bring in what we call the diamond. So the diamond should come here and connect with an arrow like that. So now, in the diamond, here we have got the statement which says if radius is less than 0. In the diamond, it will change into is. So you say, is radius less than 0? Put a question mark. So we put an arrow going that side and an arrow going downwards. So now, the question is the radius entered less than 0? Meaning, have you entered the wrong value of the radius? Yes. So if yes, what happens? And if no, what happens? So now, if yes, you entered the wrong value of the radius, meaning you entered a number which has a negative, that is, it is less than 0. So the computer will automatically detect an error because there is no radius which has a negative. So now, because the computer will detect an error, we put a parallelogram here because the computer has detected an error and it will display that error on the screen. So in the parallelogram here, we put what is given in the inverted commas. So this is it, you write error message. So now they are saying and re-enter positive radius. So you simply draw a loop which will go back to enter there and put an arrow pointing backwards. So this loop is telling us to say, because the computer has detected an error, we're supposed to go back and input the value of the radius which is correct. So now, what about if no? What about if you entered the correct value of the radius? Then you should go ahead and enter the height. That's why it is saying else enter height. So here again we enter height. So we put a parallelogram because the parallelogram is used for entering and for displaying. So now again here we enter height, enter h, just an initial. So now after entering h, the same scenario will happen. If you entered the wrong value of the height, meaning if you entered the height with a negative, so the computer will detect an error because there's no height which has a negative. So to answer that, we bring again down. So this is our diamond here, an arrow point that way, an arrow point downwards. So now in the diamond here, we pose a question. You say, is height less than 0? Put a question mark. Here you say yes, and here you say no. If yes, the height is less than 0, what happens? The computer will automatically detect an error to say there is no height which has a negative, so it will display that error on the screen. So now because it is displaying, we use a parallelogram again for displaying. So in the parallelogram here, we write what the computer will display, what is in the inverted commas. So here we say error message. Like that. And we are told to say, and re-enter positive height. So we draw a loop which is going back to enter height. So a loop will go that one. And put an arrow to show that you have gone back to enter the correct value of the height. What about if not? What about if the height entered was correct? Then it means the computer will go ahead and process. So now that's why here to say, else volume is equals to, they have written the formula for us. Pi star square radius star height. This is where the computer is now processing, meaning what was entered was correct. So now when processing, we use the rectangle. So now here you put the rectangle. And in the rectangle here, you simply put the formula which is given in the question. So the formula says volume is equals to, here we are told pi square radius star height. This means volume is equals to pi r squared height. And that is the volume of the cylinder, which simply means this whole program is for calculating volume of the cylinder. So now, on the flowchart, multiplication is interpreted as a star. So this will mean volume is equals to pi r height. So after the computer has processed, here we are seeing end if. The end if weight has got no parts on the flowchart. They are simply telling us to say the computer has ended its job. So it will automatically display the answer on the screen. So it will display the volume. So to display, again we bring in the parallelogram. So the parallelogram will come in this manner. So we connect with an arrow like that. So here, because the computer is displaying, therefore we will simply write what the computer will display. So here, we are going to display the volume. So we say display V, just a V. Then after that, we stop. So meaning everything has been done. Again, we connect with an arrow and write the word stop inside there. So this is the flowchart which corresponds to the pseudocode given here. Remember, this pseudocode, these are simply, they are always similar. What's just different is when it comes to the formula here. The formula might be different, but this is the general appearance of how a flowchart will look in such kind of pseudocode. Remember to hit the bell for new videos and consider subscribing. See you next time.